Welcome to Simply Logical, this is Venkatesh. Interview puzzles are critical thinking problems much like brain teasers. In this video, I am presenting 10 such interview puzzles which are commonly asked in interviews. Feel free to pause the video after each puzzle and try yourself before checking the solution. Let's everyone know your answer in the comment section. So let's check the puzzles now. You have 3 switches in a room. One of them is for a bulb in next room. You cannot see whether the bulb is on or off until you enter the room. What is the minimum number of times you need to go into the room to determine which switch corresponds to the bulb in next room? So to simplify, there are 3 switches in a room where one of them is assigned for a bulb in the next room. You can't see whether the bulb is on or off until you leave the room. Find the minimum number of times you have to go into the room to identify which switch corresponds to the bulb in the other room. This question has been asked several times during different analytics-based interviews. Give a try before checking the solution. Let me explain the solution now. As I have already told, this 3 switches and 1 bulb puzzle is a very famous interview puzzle. The answer to this puzzle is 1. You need to enter the room only once to determine which switch corresponds to the bulb. Let me explain the solution in detail. First, switch on the first switch and wait for some time, say 5 minutes. Now switch off the first switch and switch on the second switch. Now enter the room. If you find the light bulb glowing, then the second switch corresponds to the bulb. If the light bulb does not glow, just touch the light bulb to check if it emits heat. If the bulb exhibits at least some heat, then the first switch corresponds to that bulb. If the bulb does not exhibit heat, then the third switch corresponds to the bulb. Let me repeat the solution now. You need to enter the room only once. First, you switch on the first switch and wait for some time, say some 5 to 10 minutes. Now switch off the first switch and switch on the second switch. Enter the room. If you find the light bulb glowing, then the second switch corresponds to the bulb. If the light bulb does not glow, just touch the light bulb to check if it emits heat. If the bulb exhibits at least some heat, then the first switch corresponds to that bulb. If the bulb does not exhibit heat, then the third switch corresponds to the bulb. So by following these simple steps, you can identify which switch belongs to the bulb easily. You have 10 boxes that contains balls with each of the ball weighing 10 grams precisely. Now among the boxes, one of the box comprises of defective balls with each defective ball weighing 9 grams. You have been provided with an electronic weighing machine, but you are allowed to use it only once. Can you find the box with the defective balls? The puzzle looks difficult, but by the time you understand the solution, you will find that it was way easy than you were thinking. For convenience sake, let's name the boxes from 1 to 10. In order to solve this problem, you have to leverage the fact that you know exactly what each good ball is supposed to weigh and what each defective ball is supposed to weigh. Many of us instinctively will take one ball out of each box and try to find a way to make it work, but the trick is to take different number of balls from each box. The number of balls you pick from each bag is equal to the box number. For example, pick one ball from box 1 2 balls from box 2, 3 balls from box 3, and so on, and finally 10 balls from box 10. In total, you will have 55 balls. If all of the boxes have good balls, then the total weight of these balls would be 1 plus 2 plus 3 plus till plus 10 times 10, which is equal to 550 grams. This is because each ball weighs 10 grams. 550 grams is not possible because we are already told in the puzzle description one of the box comprises of defective balls with each defective ball weighing 9 grams. So this is the catch to solve this puzzle. If box 1 has defective balls, then the total weight should be 1 gram less than expected. It is because only one ball weighing 9 grams. If box 2 has defective balls, then the total weight should be 2 grams less than expected. It is because 2 balls weighing 9 grams. Similarly, if box 3 has defective balls, then the total weight should be 3 grams less than expected. It is because 3 balls weighing 9 grams. So once you weigh the set of chosen balls, find out the difference between the total weight and the expected weight. That number represents the box number which contains the defective balls. By following these simple steps, we can solve this puzzle and defective box can be identified with single weigh. There is an equilateral triangle and 3 bugs are sitting on the 3 corners of the triangle. Each of the bugs picks up a random direction and starts walking along the edge of the equilateral triangle. What is the probability that none of the bugs crash into each other? This is a fantastic puzzle asked in several job interviews. Feel free to pause the video and give a try before checking the solution. Once done, keep watching the video for the right approach. Here in this puzzle, every bug has 2 choices. Pick either of 2 edges, go through the corner on which bug is initially sitting. If you have come up with the fact that the bugs can avoid the collision only when they decide to move in the same direction, be it clockwise or anti-clockwise, you have already solved off of it. In any other way, the bugs will definitely run into each other. Now the bugs can move either clockwise or anti-clockwise. The probability of choosing a specific direction is then 1 over 2. We will utilize the simple equation of probability to find out our answer. The probability of no collision equals probability of the bugs move in clockwise direction plus probability of the bugs move in anti-clockwise direction. Probability of the bugs move in clockwise direction is 0.5 times 0.5 times 0.5. This is because there are 3 bugs and each bug have 2 options, either moving in clockwise or anti-clockwise direction. Similarly, the probability of the bugs move in anti-clockwise direction is 0.5 times 0.5 times 0.5. This is because there are 3 bugs and each bug have 2 options, either moving in clockwise or anti-clockwise direction. Hence, probability of no collision equals 0.5 times 0.5 times 0.5 plus 0.5 times 0.5 times 0.5, which is equal to 0.25. Thus, the probability that the bugs won't collide into each other is 0.25 or 1 over 4 or 1/4. This is a clever probability interview puzzle asked by many companies. Be prepared for this if you are preparing for interviews. At a party, everyone shook hands with everybody else. There were 66 handshakes. How many people were at the party? This is one of the most frequently asked interview puzzles. Feel free to pause the video and give a try before checking the solution. I will be back in 10 seconds. Let me explain the solution now. Let's suppose that there are n number of people in the party. The first person will shake hand with n minus 1 people. The second person will shake hand with n minus 2 people. The third person will shake hand with n minus 3 people. In this way, n minus 1th person, that is, last but one person, will shake hand with n minus 1, which is equal to 1 person, that is the last person. Now add all the number of handshakes, n minus 1 plus n minus 2 plus n minus 3 plus so on till 3 plus 2 plus 1. If you observe this particular series carefully, this is nothing but the sum of n natural numbers, but only difference is here the n is n minus 1. We know that the sum of natural numbers formula is obtained by using the arithmetic progression formula, where the common difference between the preceding and succeeding numbers is 1. Natural numbers are also called counting numbers, start from the number 1 until infinity, such as 1, 2, 3, 4, 5, 6, 7 and so on. Sum of n natural numbers formula is represented like this: n times n plus 1 over 2, where n is the last number. In this case, we know that n is n minus 1, hence formula becomes n minus 1 times n minus 1 plus 1 over 2. After simplification, formula becomes n times n minus 1 over 2. Also, we know that in the puzzle, the total handshakes given are 66. Hence, the equation becomes n times n minus 1 over 2, which is equal to 66. After simplification, it becomes n times n minus 1 equals 132. Further simplification results in n square minus n minus 132, which is equal to 0. This is nothing but the quadratic equation. After solving quadratic equation, we get n minus 12 or n plus 11 equals 0. Here, either n equals 12 or n equals minus 11. Since number of people can't be negative, n will be 12. Hence, there are 12 people in the party. By following these simple steps, we can solve this puzzle in less than 30 seconds. In this visual brain teaser, you can see 3 glasses on the left that are full and 3 on the right that are empty. You can only move one glass to make a row of alternately full and empty glasses. Which one do you move? This is an interesting brain teaser, requires out-of-box thinking. Feel free to pause the video and give it a try before checking the solution. Let me explain the solution now. For convenience sake, let's name the glasses A, B, C, D, E, F. A, B, C, D, E, F are 6 glasses. A, B, C are full and D, E, F are empty. They are placed in a row. The important point here is, in the brain teaser, it is mentioned that you can only move one glass. But there are no rules mentioned on the restrictions on operations that can be performed on that glass. So what we can do is, we have to move the full glass B and to pour total juice or water of it from glass B to the glass E. Then put the empty glass B in its own position. After performing this activity, B glass is empty and E glass is full. Now the row will be like this: A is full, B is empty, C is full, D is empty, E is full, F is empty. Thus, by moving only one glass, we can make a row of alternately full and empty glasses. A snail creeps 6 feet up a wall during the daytime. After all the labor it does throughout the day, it stops to rest a while, but falls asleep. The next morning, it wakes up and discovers that it has slipped down 2 feet while sleeping. If this happens every day, how many days will the snail take to reach the top of a wall 18 feet in height? This is a clever logical puzzle. Feel free to pause the video and give it a try before checking the solution. Once done, continue watching the video for the right answer. Let me explain the solution step by step. According to the puzzle, a snail creeps 6 feet up a wall during the daytime and it slips down 2 feet while sleeping. So on the first day, the snail climbs up 6 feet and slips down 2 feet while sleeping. So next morning, it is 4 feet from where it started. The snail thus travels 4 feet upwards every day. Therefore, in 3 days, it has travelled a distance of 12 feet from the bottom. Here lies the catch to the problem. On the last day, the snail travels 6 feet upwards and hence reaches the top of the wall in a total of 4 days. So, snail requires 4 days to reach the top of the wall. Let me explain the alternate solution through equation. Let x be the number of days the snail takes to reach the top of the wall 18 feet in height. On the last day, the snail will reach the top by traveling 6 feet upwards and there will not be any question of slipping down. The number of remaining days excluding the last day are x minus 1. Since the snail climbs up 6 feet and slips down 2 feet while sleeping, it travels 4 feet upwards on each of these remaining days. Thus, distance travelled on last day plus distance travelled on remaining days equals wall height, or 6 plus 4 times of x minus 1 equals 18. On solving this equation, we get 4 times x minus 1 equals 18 minus 6, which is equal to 12, or x equals 12 over 4 plus 1, which is equal to 4. So, snail requires 4 days to reach the top of the wall. Out of 200 fish in an aquarium, 99% are red. How many red fishes must be removed in order to reduce at 98%? This is an amazing math puzzle. Though looks simple, it is more trickier than we think. Let me explain the solution now. Initially, we know that total number of fish given is 200 and 99% are red, 1% non-red. Since only red fish must be removed, indirectly the question says that number of non-red fish must be constant. As per the question, initially 1% of fish are non-red, that is 1 over 100 multiplied with 200, which is equal to 2. Currently the percentage of red fish is 99% in the aquarium full of 200 fishes. So total red fish is equal to 198 and non-red fish equals 2. Let's say after removing x red fish, the percentage of red fish becomes 98%. This can be represented in the form of equation like this: 198 minus x over 200 minus x equals 98 over 100. 198 minus x represents number of red fishes in aquarium after removing x red fish. 200 minus x represents total number of fishes remains in aquarium, which includes non-red fishes as well. RHS represents the percentage what we need to achieve. So let's solve this equation. After simplification, equation becomes 50 times 198 minus 50x equals 49 times 200 minus 49x. So x equals 9900 minus 9800, which is equal to 100. So now x equals 100. So it is tough to imagine that we will have to remove 100 fishes out of 198 red fish to bring the percentage down by 1% in a total of 200 fishes. The point to be paid attention is that when we are removing the red fish from the aquarium, we are decreasing the total number of fishes in the aquarium. So had we been converting every red fish taken out to a non-red fish and kept them back in the aquarium, only converting 2 red fish to non-red would have brought the percentage of red fish in the aquarium down to 98%. When something is subtracted from both numerator and denominator, the overall effect on the fraction is quite small, especially if numerator and denominator are large compared to the small amount subtracted from both. In this question, if you remove 2 red fish out of the 198 red, the new percentage is 98.989898, which is quite close to the original 99%. In fact, when a small amount delta is subtracted from both numerator and denominator, the change in the value of the fraction is a small number new delta, and the increase in delta is proportional to the increase in new delta, which is also the decrease in the value of the fraction. Here the fraction value decreases approximately by 0.005%. When we decrease the number of red fish by 1, this rate of change can be calculated by differentiating the above equation. And this is another way to solve this question. So we have to remove 100 red fish, so the number of red fish in total becomes 98%. It is quite unbelievable answer. The difference of percentage is 1, but the difference in number is 100. A farmer lives on 1/4 of his farm, the area marked A. He decides to divide the remaining 3/4 of the farm between his 4 sons. How should he do this if the area and shape of the 4 farms must be exactly the same? You can achieve this by adding 8 matchsticks. Let me repeat the puzzle. A farmer lives on 1/4 of his farm, the area marked A. He decides to divide the remaining 3/4 of the farm between his 4 sons. How should he do this if the area and shape of the 4 farms must be exactly the same? The condition is you have to achieve this by adding 8 matchsticks, not less or more than that. This is one of the hardest puzzles and it requires out of the box thinking to achieve the correct solution. Feel free to pause the video and give a try before checking the solution. If you are new to the channel, do consider subscribing to the channel. Let me show the solution with graphical representation. Suppose you have a regular hexagon made up of matchsticks with 3 diagonals in it. The task is to convert the given hexagon into 3 equilateral triangles by moving only 4 matchsticks. Before actually getting into the problem, let me explain what are hexagon and equilateral triangle. A hexagon is a 6-sided 2-dimensional geometrical figure. The total of the internal angles of any hexagon is 720 degrees. A regular hexagon has 6 rotational symmetries and 6 reflection symmetries. All internal angles are 120 degrees. An equilateral triangle is a triangle in which all 3 sides and angles are equal. All 3 internal angles of equilateral triangle measure 60 degrees. Let's get into the puzzle now. Here is a regular hexagon made up of matchsticks with 3 diagonals in it. The task is to convert the given hexagon into 3 equilateral triangles by moving only 4 matchsticks. Let me explain the solution now. Solution can be achieved by moving 2, 4, 5, 6 numbered matches to get exactly 3 equilateral triangles. First move matchstick 4 adjacent to matchstick 7. Next move matchstick 6 adjacent to matchstick 8. Next move matchstick 5 and connect to mastic 6 and it forms the base for the part of the triangle 3. Finally, move mastic 2 and connect to mastic 4 and 5 which forms the complete base for the triangle 3. Now we can clearly see that there are 3 equilateral triangles. 2 triangles are formed with side equals single mastic, whereas third triangle formed with sides 2 mastics. You have 4 bottles of milk. One of them is poisonous, while the other 3 are non-poisonous. There is a rat which dies exactly after 10 hours of drinking the poison bottle. You have a clock that measures time only in hours. Suggest an optimal strategy to identify the poisoned bottle within 24 hours. Sometimes it can be asked to find the minimum time required to find the poison bottle. So this is a simple puzzle. Now I will explain the logic to find the poison bottle in a minimum time. First of all, label all the bottles from 1 to 4. At the beginning of the first hour, feed the rat the first bottle. And then at the start of second hour, feed the second one, and similarly at the start of third hour, feed the third bottle. Remember, there is no need to feed the fourth bottle at the start of fourth hour because if the rat does not die after feeding 3 bottles, obviously the poison bottle will be 4. Let's analyze the outcomes. If the rat dies exactly after 10 hours, the first bottle is poisonous because this is the first bottle which is fed to the rat, and as per the problem statement, rat will die exactly after 10 hours of drinking the poison bottle. Hence, if the rat dies after exactly 10 hours, then the poison bottle is first bottle. If rat dies after 11 hours, second bottle contains poison because second bottle was fed to the rat at the start of second hour. 1 plus 10 is 11, hence if rat dies after 11 hours, second bottle is poisonous. If rat dies after 12 hours, third bottle contains poison because third bottle was fed to the rat at the start of third hour. 2 plus 10 which is 12, hence if rat dies after 12 hours, third bottle is poisonous. And if the rat does not die even after 12 hours, definitely the fourth one is poisonous and you don't have to wait till 13th hour to find out whether it's true or not. So thus after exactly 12 hours, you would be able to determine the poisonous bottle. So let me repeat the logic. You don't even need 24 hours to find out which bottle is poisonous. Logic is feed the milk sample to the rat after each hour and note down the time. If the rat dies after 10 hours, then the first one is poisonous. If the rat dies after 11 hours, then the second one is poisonous. If the rat dies after 12 hours, then the third one is poisonous. And if the rat does not die even after 12 hours, definitely the fourth one is poisonous and you don't have to wait till 13th hour to find out whether it's true or not. By using this simple trick, you can find the poisonous bottle within 12 hours and you don't need 24 hours.